To perform further drill down, the analyst can dive into the behavioral plane by clicking on the behavioral plane button to see the timeline visualization. This segregates the alerts into behavioral planes automatically from the raw netflow traffic. The analyst no longer needs to investigate individual entities or silos of security data in a swivel chair fashion using multiple tools. Alerts are correlated across the entire network based on behavioral commonalities. This allows the analyst to pivot across entities and assets that have exhibited similar anomalous patterns. The analyst can also download evidence associated with the asset's selected timeline for further investigation or collaboration with external agencies. Now, the analyst can launch the hunt directly from the screen by selecting Begin Hunt. The Hunt Playbooks app contains a repository of hunts that have been created by the analyst of the security team, as well as hunts that are prepackaged in the product. Existing hunts can be replicated as is, or can be forked to create new hunts based on a variation of the original hunt. This allows junior analysts to take advantage of complex hunt scenarios already created by experts, adjust them as needed, thereby leveraging the tribal knowledge of their senior colleagues. The collaborative feature of the Hunt Playbooks library enables any organization to be able to create a list of hunts which is very specific to their organization itself and aligns with the security context of that organization. If the existing hunts do not provide the hunt flow needed, the analyst can start a brand new hunt. The analyst simply clicks on the new ad hoc hunt button. He or she can select the hunt dataset, in this case NetFlow, and then select the time period where anomalous events are reported by the AI engine, in this case 48 hours of raw NetFlow logs. Now the analyst can enrich the raw logs with contextual information on critical infrastructure, authorized whitelists, geolocation, and threat intelligence. Now we aggregate the number of connections and bytes transferred between the endpoints in the NetFlow logs on a per-hour basis, resulting in an aggregated data set with 48 hourly points, which can be now used to transform this data set into a graph visualization. This table will be converted into a graphical representation accompanied by a time bar to display the graph at any particular time interval within those 48 hours. To select a particular node, we go to the asset list and search for the node, in this case FR-CN-5. As soon as we search, the desired node starts flashing. In order to further limit the graph analysis, we can apply additional filters such as a whitelist filter. At this point, we have applied all the filters we need to reduce the graph substantially. Now, we want to apply analytics functions to the graph to show us anomalies that may not be visible to the naked eye. We want to see if there has been any irregular cross-community connections that would typically indicate erratic and oftentimes malicious behavior. The analyst does not need to look at millions of logs, but rather rely on the AI capabilities of the suite. The analyst can click on the function in the anomaly list to automatically take them to the exact time interval and zoom to the edge where this anomaly was reported. He or she can click on the edge and it will show the edge properties of the anomaly connection. Now that he or she knows that this connection is malicious, the analyst can provide feedback to the AI engine directly. In this way, the analyst is further training the algorithms so that when similar behavior is observed, it will be flagged as anomalous automatically.